Section 2.1.2 Ego's rotation. Vertical and horizontal movements of ego do not suffice for the inspection of the virtual lab and its various instruments and objects. The user may also use the mouse in order to revolve around themselves as well as to look up and down within specific limits. We conventionally call those movements horizontal and vertical rotations. In the ego controller script, we define the global variables responsible for the rotation of ego, rotate vertically and rotate horizontally. We also create, like before, global float variables, which are public too, so their values can be set in the Unity editor, defining the angular speed in both directions, angular horizontal speed and angular vertical speed. Horizontal rotation, meaning the rotation of ego game object around itself, is triggered by the horizontal movement of the mouse and achieved through this block of code in the update function, which is similar to the movement code blocks we saw before. The only essential difference is that here we achieve rotation by altering the y-coordinate of the local Euler angles vector of ego's transform. Vertical rotation, on the other hand, triggered by the mouse's vertical movement, means not the rotation of ego itself, but instead the rotation of ego's child camera. That is, increasing and decreasing the latter's x local Euler angle. To implement it, we declare a transform global variable for storing the reference to ego's child camera and its appropriate initialization in the script's start function. As we have already seen in the scene hierarchy, ego has only one child, camera. Therefore, the latter's reference is captured by the transform. Now let's see the update function. Instead of the ego transform itself, we see two more new things. First, a particular function within vertical rotation limits needs to return true. That is, as its name suggests, the camera's x angle must be within its vertical rotation limits in order for the same angle to change accordingly. Second, unlike before, there is no time delta time involved in the calculations, cause for this particular case it is of no need. The Boolean function within vertical rotation limits has this particular code. Here, minimum x angle and maximum x angle are constants, set to -70 and +70 degrees respectively, which, as their names suggest, define the lowest and highest x angle values that the camera's x angle is allowed to get. As for the reduce function, it simply returns the equivalent of an angle in the range between -180 and +180. Now let's test our code. In the inspector for ego, in the ego controller script, we set angular horizontal speed to be 100 and angular vertical speed to be 2. And then we press play. Now, by moving the mouse up and down or left and right, we achieve the rotation of ego in all directions, as we plan to.